All right. This first graph, this one over here, is the partial sampling distribution of p hat. I'm leaving out the partial just because I don't have a lot of room. What is a sampling distribution? We made them yesterday. What is it? How did we make it? Took a select group of people. How many people did we do yesterday? 10. So right here you'll notice it says n equals 10. And what did I have you do with those 10 people to make this graph right here? Yeah, the proportion of people out of those 10 that passed. To be a full sampling distribution, we would need every possible group of size 10 from those 253 students that are on page 5 in your notes. This is just a partial sampling distribution because we didn't do every single possible group of size 10.
That would be ridiculous.
That would be a little bit ridiculous. Technology can do every single possible grouping of size 10, but that's a bit much for us. What does p hat mean? What does p hat mean?
The proportion of that, a single random sampling of 10 students and the proportion calculated from that sample.
Yes. Guys, focus please. P hat is a sample proportion. So every single one of these dots is a different p hat. We use this sampling distribution to try to estimate p. What did p mean again? The true proportion of what? Of all AP Stat students in this district that passed the exam. So we're using the sampling distribution of p hat to try to estimate what the true proportion is. This graph over here, the one on the right, this is the sampling distribution of X bar. If p hat is a sample proportion, what does X bar mean? Sample mean. Is this the entire sampling distribution for X bar or a partial sampling distribution for X bar? Partial. What would it need to be a full and complete sampling distribution for X bar? Every possible group of size 10. We did not do that. So we have a partial sampling distribution for X bar, and our goal is to use this to estimate what? What do we want to estimate? The mean, the true mean, which is mu. The true mean for all AP Stat students in this district. And again, we had samples of size 10. All right. Number 2, I'm going to have you guys read number 2 to me, but I'm not going to move off this screen because it asks you to draw on these 2 graphs. So what does the first part, the first sentence in number 2 say? The true proportion of all AP Stat students in this district that pass the AP exam is 0.652. If that's the true proportion, then what should we label it as? P hat. P. P hat would be a sample proportion. This is P because it's the true proportion. I'm going to add this to the picture. 6.52 would be about here. So P equals 0.652. what's the second sentence on number 2 say?
The true mean AP exam score for all AP staff students in this district is 3.1.
The true mean AP exam score for all AP stat students in this district is 3.11. What should we label 3.11 as? Mu. So on my graph, that would be about here, a little bit over, more like this. Mean mu equals 3.11. Number 3, did the class mostly overestimate or underestimate or neither the true proportion and the true mean? Look at the true proportion. Here's where the true proportion is, 0.652. It's located about where on our sampling distribution?
About in the middle.
About in the middle. So did we do a bad job of estimating this?
No.
No, we didn't consistently overestimate, we didn't consistently underestimate. We did an okay job with this one. What about with our means? Looks like we underestimated a little bit. Did we do a really bad job at it? No, it's still about in the center. What do you think would happen if we added more samples?
It was closer.
Probably get closer and closer to the mean. Okay, so I'm going to flip over here. Again, if you did not label these already, please label the 6.52 as P and the 3.11 as mu. And so then my answer to number 3, I'm going to say neither. About half of the estimates are too high and about half of the estimates are too low. Not exactly, but we did an okay job with this. When the mean of the sampling distribution is about the same as the parameter, then we say we have an unbiased estimator. What am I trying to say when I say the mean of the sampling distribution?
Taking the average of all of those, taking the average of all of these statistics.
Mm-hmm. The average of all of the statistics, which should be found where in the sampling distribution? In the middle. Yeah. The mean of our sampling distribution is the center, or the average. And it will do a good job of estimating our parameter, which might be P, it might be mu, it might be sigma. The true proportion, the true mean, the true standard deviation, whatever thing it is that we are interested in. If it's for the whole population, that would be a parameter. I want to talk about this for just a moment, where it says unbiased estimator. Do you guys remember when we did the Beyonce Crazy in Love activity? All right, so I have those graphs up here. They're a little worse for wear, but they're still up. This one over here was when I had you guys just pick out 5 words, go. We called that a convenience sample. Did this one do a good job of estimating the true average word length? No, here's the center of our distribution. Here's the true average. This is a biased estimator. This is what I had you do it after taking a simple random sample for the first time. Was this one an unbiased estimator?
Yeah.
The true average was 3.53, and the center of our distribution was at about 3.6. This is an unbiased estimator. The center of this distribution is approximately centered where the true mean actually is. This one is a biased estimator. We want unbiased estimators. So we're going to use our sampling distributions to try to get an unbiased estimate. All right, number 4, what happens if we increase sample size? Yesterday I had you take random samples of what size? 10. Today I want you to take random samples of size 20. How many samples do I want you to take? 3, just like yesterday. You're going to calculate the sample proportion and the sample mean, just like yesterday. We're going to do this in 10 minutes. You guys have 10 minutes. Do you guys remember how to do the random sample on the graphing calculator? Math, over to probability, option number 8. What's the lower boundary? 1. The upper boundary? 253, and we want n to be 20 this time. You won't be able to see all the numbers on the screen, so you have to use the back and forth arrow, but make sure that you don't touch any other buttons or it won't let you go back and forth anymore.
So there's no way to like just make it like right 1 to 5, like connect it that way?
No, unfortunately. Now, question. The numbers that the calculator spits out, are those the numbers that you're finding the average of? No, that just tells you which people to go and pick out. You guys have 10 minutes to accomplish this. 10 minutes.
This is great.
Make sure that you're listing out the scores on the line and not the random numbers. So when you go to page 5, this is the AP exam score for different school districts. These random numbers here are picking out the students. You need to then go match the number of the star to find what their scores. And we'll find person 16. They got a 4. That's going to be the first number that you write down on this line right here. And then you're going to go find person number 105, and you're going to write down their scores. Person number 87, person 201, and scroll over to get where I'm. Don't hit any other buttons on the calculator until you have all of these, because if you hit anything else, if you try to do something else, it won't go back and forth on the same thing. So you want to see all the numbers. Please let me know if you guys need any help. Oh, okay, so this calculator. So this is going to take, if you want it to be not one, it's going to take all 20 numbers. It's come up. It's going to be the first one. Yep. If you want to grab the other calculator, let's put in that parameter. And I guarantee you, I won't have you do this on the test, so like don't worry about that particular piece. But yeah, the color ones that you do, I only want the first 20. This one's color. Right, exactly. And it's color too. Like you can wrap in different colors.
Okay, I'm done. With the first row. Okay.
You guys think you can be finished in the next 5 minutes?
Well,
Okay, I'll check in with you again in about 5 minutes and see where we're at.
We kind of like really person guys.
It is a lot.
Yeah, we're supposed to advertise this.
Yes.
We're not. We ain't never finished.
The proportion.
Well, mine is here to finish, so.
No way.
I'm just now starting the third. There's no way.
you're done too, dude. I'll let you go ready. I'm about to get a freaking migraine, bro. These systems at work, bro. And it's the average of 3 and up, right?
Scores of 3 and up are passive. So calculate your proportions first. Count how many are 3s or higher. Take it out of 20 and write it down as a decimal.
I don't know. No, I didn't do it. I was here. I didn't do it. I locked it on my phone. No distractions. It's supposed to be for the time. But yeah, now instead of sharing, I just saw you.
After you're done with your app, just change this.
Okay. It makes you want to do yeah, like that.
How we doing?
Plus, I'm just
Pretty easy.
it's 9
Nice answer.
first, and then I just I 3 water.
If you are done with your proportions, or rather when you get done with your proportions, come and put your dots up for your proportions. Then you can go back and calculate the means. But once you have the proportions done, come and put up 3 dots, 1 for each proportion.
I thought 3.1 for all my.
How many half?
Yeah. What's the probability of that being probable?
Actually, you know,
Very improbable.
So the proportion that passing score is a 3 or higher. And then if you want to, since you have your means, like you don't have to You can feel free to put your means up as soon as you have those as well. Put your proportions up first, and then put your means up.
Do you not know why you have been trust? Do you not know why you've been trust?
Yes, so all the numbers here that are 3 or higher, count all those up and then divide by 5. Right. Again, once you have your proportions, put those up, and once you have your means, put those up as well.
I got it. I got that.
You got 5.9 and 6.1. How can you get something bigger than 5?
If we actually could do it.
She's not the
You
type.
divide by 1.
No, she's not the type. I'm not hearing the rhythm.
I can wait about 2 more minutes. We're going to get as many dots up as we can in the next 2 minutes. If you don't get your dots up, that's going to be okay. We're going to move on.
That would be why I didn't see, right?
I'm not looking at all my brain.
Get your sample proportions and your sample means up. There, those look much better. You're like, mine don't fit on the muffles.
I divided that by 2.
I figured that's what happened.
I didn't see only 10. I had only about 55 instead of 5, so I was just like, that doesn't right.
Did he bother?
Yes,
I had. He went to the game. I had 8 out of 10.
She's trying to my friend.
No, he was at Frankfurt. He went to the game. Now he's 8 out of 10. Why did you? Like nobody else knows this, bro. You're not Indiana. We made my bell show.
All right, we got about 1 more minute where I can wait. All
Joseph no. Joseph.
right.
He need help.
Please go ahead and start copying these into your notes as well. Please, and they don't have to be perfect. I just want the basic shape in your notes. All right. It's okay. Oh. Nope, you're good. That's fine. All right. This one over here is the sampling distribution of p hat. Please get these copied into your notes. Sampling distribution of p hat.
And again, it doesn't need to be exact, right?
It does not have to be exact. No. That's okay. Give me just a second. I'll get it right here. All right. Push it up.
I got 2.71. I was sick. Get to that good.
All right. This is the sampling distribution
I think it's very long.
of X bar. What is the difference between these sampling distributions and the ones that we did yesterday?
What is the
Is there just a pile at 0.6?
Basically, yeah. What are the differences between yesterday and today? Which one's more spread out? One from yesterday is more spread out. So what changed in what we were doing? What did I have you do that was different than yesterday? More. I had you do it with 20 instead of with 10. The dot plots when we have samples of size 20 compared to samples of size 10, I have less variability now. It's less spread out. Yesterday's was more spread out. It was wider. Just basic shape. Worry about basic shape. Middle is somewhere between 3 and 3.1. Remember, right about here is P, 0.652. And right about here is mu, 3.11. Big takeaway that I want for you guys today. As n goes up, variability goes down. What is n? Sample size. What do I mean by variability? Standard deviation, or it could be variance, or it could be IQR, or range. We're talking about spread here. When I say variability, I'm talking spread. Most of the time, you're right. We use standard deviation for that. When the sample size goes up, the spread goes down. The sample size goes up, spread goes down. Variability goes down. All right. All right, you guys ready to flip the page? Let's take this over to page 8. Take this over to page 8. Important takeaways for today, our learning targets for today. Biased versus unbiased estimators and the impact of sample size. A biased estimator consistently overestimates or consistently underestimates the true population parameter, like we saw with Beyonce. If it is biased, it consistently overestimates, like we did, or consistently underestimates. Unbiased, the mean of the sampling distribution is equal to the population parameter. Not if we have the entire sampling distribution. If we have the whole sampling distribution, it will be exactly the same. This would be the center or the average. The mean or the center, the average of the sampling distribution is equal to the population parameter if it's an unbiased estimator. Sample size, as n goes up, variability goes down. A good statistic has low bias so that it's accurate, and low variability so that it is also precise. We want this to be narrowed right around the true parameter. We want it to be centered around the true parameter, and we want it to be narrow so that there's not much variability. We are precise here. Most of our estimates are getting very close. What'd you say? Yes. Yes. So, like when I look here, do you see how this is all kind of piled together? That's what I want. I want to see it closer together. Let's go look at the check your understanding now. The The James family has 5 children: Jocelyn, age 8, Elise, age 8, Michael, age 14, Erica, age 16, and Sarah, age 18. Complete the table by listing the 10 possible samples of size n equals 2. So we're picking out 2 kids, and we are averaging their ages. They started it for us. They picked out Jocelyn and Elise. So then we take Jocelyn's age 8 and Elise's age 8. We add them together and divide by 2. And so we get an average of 8. What are the other possible arrangements of 2 kids from this family? Jocelyn and Michael. What else? Got Jocelyn and Michael, and we could do Jocelyn and Erica, Jocelyn and Sarah. Or I could do Elise and Michael, Elise and Erica, Elise and Sarah. Michael and Erica, Michael and Sarah, or Erica and Sarah. Please go through and find those averages. Average their ages. So take the 2 people's ages, add them together, divide it by 2 because you have 2 people in your sample. Calculate all of those average ages for me. What would the average for Jocelyn and Michael be? 11. Jocelyn and Erica. Jocelyn and Erica.
12.
Jocelyn and Sarah. Elise and Michael.
11.
Elise and Erica. Elise and Sarah. Michael and Erica. Michael and Sarah. Erica and Sarah. Perfect. We're going to make a dot plot now with those ages. So make a dot plot with those 10 dots. Make 10 dots on your graph. Ten dots on your graph. Should look like this. Is this the complete sampling distribution or partial? Complete. Why? We have every possible arrangement of 2 siblings together. We have every possible arrangement. So this is the full sampling distribution. I want you to calculate the mean, calculate the average for the sampling distribution. So using the numbers from the table, calculate the average. Using the numbers from the table from our sampling distribution, calculate the average. What'd you say? 12.8. How did you do that? How did you get 12.8?
I ended up all the dots divided by 10.
Yep, add up all the dots, divide by 10, so kind of like this. I didn't write down all the numbers, but I showed what I was doing. 8 plus 11 plus 12 plus 13 plus blah, 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 plus 16 plus 17 divided by 10, we get 12.8. How would you calculate the mean for the population? What is the population here? The children, the 5 children. Calculate the average age for the 5 children. Yep, add up the 5 kids' ages and divide by 5. What do you get? 12.8. So this first average is the mean of X bar. This is our sampling distribution average. This one over here is my population average. This is the mean of X versus the mean of X bar. Is the sample mean an unbiased estimator for the population mean?
Yeah.
Yes. Why?
So it's like,
Yes. The mean of the sampling distribution is the same as the mean of the population. It's an unbiased estimator because the mean for the sampling distribution is exactly the same as the mean for the population. What if I had you take samples of size 3 instead of samples of size 2? Would the variability of the sampling distribution of the sample mean be larger, smaller, or about the same? Smaller. Why?
But the sample size is larger.
Yep. As n goes up, the variability goes down. Increasing the sample size, n up, decreases the variability. Most of the time, do you think we're going to make a full sampling distribution? No. This was a nice example though because it was a small enough sample size, or sorry, small enough population size that we could do the entire sampling distribution. We could do every single group of size 2, and we got to see that the average for our sampling distribution was exactly identical to the population average. Homework is due tomorrow. Homework is due tomorrow. If you need another copy of the homework, it's found in the back of the room in the blue organizer, very bottom paper. For the first time in a while, it's just a front back. It's not 4 pages long. It's just a front back on this one.
You.
Due tomorrow.
I still feel like I was like.
Due tomorrow.
I still feel like.
Oh, that's the.
I was